Hi, for question number 1, use the method of differences to find the summation of r going from 1 to n for 1 over 2r all squared minus 1, and also deduce the value of the summation of r going from 1 to infinity, 1 over 2r squared minus 1. 5 marks for this question. Now then, to do a question like this, first of all I would express this in partial fraction. Now this part here could be expressed in partial fraction as 1 over 2r square, so that means 1 square, so 1 over 2r minus 1 times 2r plus 1. So if we were to express this in partial fraction, we can say a over 2r minus 1 plus b over 2r plus 1. So we can let r is equal to half. If we do that, first of all I've got 1 is equal to a times 2r plus 1 plus b times 2r minus 1. Now if we were to substitute r is equal to half in here, that's going to make it 1 plus 1 is 2, therefore a is going to be half. Obviously, if we do for b, we substitute r is equal to minus half and also let r is equal to minus half, then b is going to be minus half. Minus half here, this is going to cancel out. Minus half here, it's going to become minus 1 minus 2, so here we are. Therefore, this can be re-expressed as the summation of r going from 1 to n over, 1 over 2r squared minus 1 is exactly the same as the summation of r going from 1 to n into a, so that's going to be 1 over 2, because this is half, 2r minus 1, then minus b, because this is minus half, so 2 over 2r plus 1. And from here we can let r is equal to 1. If we do that, what's going to happen? The summation is going to be 1 over 2 times 1 is 2, 2 minus 1 is 1, 1 times 2 is 2. So we're going to get plus half, then minus 2 times 1 is 2, plus 1 is 3, so this is going to be 1 over 3. 2 times 3. Here it's going to be 2 times 1. And if we let r is equal to 2, so that's going to be 1 over 2 times 2 is 4, minus 1 is 3, 1 over 3. 1 over 2 times 3, minus 1 over 2 times 2 is 4, plus 1 is 5. What I'm trying to observe, if a pattern is coming up here, so if this is 3, that's going to be 2 times 3 is 6, minus 1 is 5, so 2 into 5, minus 1 over 2 times 3 is 6, 6 plus 1 is 7. So what do we notice? 3, 5, 7, 1, 2, 3. This is going to cancel out with this, it's going to cancel out with this. So what about if we go further down and then we go up to, let us say, just before the last term, r is equal to n minus 1. So if we put n minus 1 here, that's going to be 2 times n minus 1, 2n minus 2. Minus 2 minus 1 is minus 3. So it's going to be 2n minus 3. Therefore we have 1 over 2 times 2n minus 3. Minus here is going to be 2 times n minus 1 is 2n minus 2. Minus 2 plus 1 is minus 1. So that's going to be 2 into 2n minus 1. And if r is equal to n, that's going to be then 1 over 2n minus 1, so 2 into 2n minus 1, and that's going to become 2 into 2n plus 1, so minus Remember, this is all these are pluses. So 2 into 2n plus 1. So what is happening here? This is going to cancel out with this. This one's going to cancel out with the one previous element just before this level here. And then what is left is we are left with half and the last term. So therefore, the summation of this series with r going from 1 to n is going to be, for 1 over 2r all squared minus 1 is going to equal to half here minus the last term, minus 1 over 2 into 2n plus 1. If you want to factorize this, you can put the half outside. You can put 1 minus 1 over 2n plus 1. So here we are for the first part of the question. Now for the second part, we need to find the summation of r going from 1 to infinity. Now infinity is a very large value. So if n is going to be a very large value here, the larger the value of n, this whole expression is going to tend to 0. So as n tends to infinity, this expression here, 1 over 2 into 2n plus 1, is going to tend to 0. And if it's going to tend to 0, that's going to be half minus 0. Therefore, it's going to be equal to half. So here we are for this question taken from Further Maths A-Level, October 2016, paper 1. Take care. Bye.